and I'm gonna take you on a deep dive into the MOOLM object system. MOOLM, to just give you an introduction, is Moo for LLMs. And Moo is inspired by Pavel Curtis's Lambda Moo that he developed at Xerox PARC. And now there's a whole lot of designs here. And what we're going to dive into is the object directory. Object system. Okay. Now, MOOLM inherits from a lot of different really good ideas. And this will take you on a tour of that. So the one important thing is MOOLM exists on the stage of a GitHub repo. And Git is over the file system. And LLMs can read and edit the file system. But Git adds parallel universes, branching and merging, and GitHub adds collaborative, PRs, code reviews, everything. So that is the stack that we're building on top of. It's industrial strength. So now the MOOLM object system, how MOOLM does objects. Self-styled prototypes over the file system, with the LLM as a universal resolver. Promoted here from where the ideas were first proven in the field, the Cauldron meta plan, skill security architecture, directory as object, per the Opus review, latent space inheritance, which generalizes MOOLM's inheritance model to use the LLM as a universal resolver. The most novel thing, and the thing least specific to the Cauldron. Cauldron is just a skill for designing, and structuring design so that you can work with a high power LLM to design and then use lower power models to execute that design step by step. So now Self and MOOLM explains how MOOLM uses a selfish inspired object system. The mechanism and the heritage, Self as an object-oriented risk instruction set via Dave Unger's SOAR, Small Talk on Risk project that he did before that. The Lisp lineage flavors from MIT, Lisp machines, CLOSS, which was when Common Lisp said, oh, we got all these different object systems in Lisp because you can roll your own and there's many approaches. How can we make an object system for designing object systems? The meta object protocol. So Common Lisp object system is CLOSS, which inherits from flavors and other things like loops. And MOP is kind of reifies how it works. It's like this reflective tower. Okay, so Gary Drescher, schema lineage, has inspired this. He was Marvin Minsky's PhD student and Leela AI's advisor, and we've discussed this with him. Piaget inspired Minsky, who inspired Drescher, who inspired Leela AI. And this is all about how do children learn by playing, and how can we make an algorithm that does that? So, but it was missing something, and he wrote it in Lisp. And Henry Minsky, my colleague at Leela, who's Marvin's son, wrote a Python implementation, but all of them hit a wall of grounding. And LLM, grounding that finally arrived. Okay, and I worked at Sun on the News Toolkit at Turing Institute with Arthur Van Hoff on Hyperlook, and Owen Densmore and David Rosenthal at Sun, who at that time filed a patent for looking at the Unix file system and the shell and paths as a multiple inheritance object-oriented programming system, just like the one that was in News that we used to build TNT and then Hyperlook, which was inspired by HyperCard. Now, taking these ideas together, it's taking a step back. Then I did a prototype called Loom, LLOOOOMM. That's kind of hard to spell, but that was kind of to learn from. And then Anthropic Skills came along, and I realized I have to throw all that away and start from scratch based on Anthropic Skills because they are fucking awesome. They are composable. And anyway, but I wanted to add things to it to make it more powerful. We've added I think we're on 10 extensions at this point and counting. But the really important ones are you can instantiate a skill. okay, and we have multiple inheritance, which like prototype-based self-like multiple inheritances. So you can have an instance, and it can inherit from several skills. Uh, then looking at the abomination that is Microsoft COM, Olay, ActiveX, um, type libraries. Even Mozilla looked at that and said, "Hey, we need something like that." XPCOM, I've used that. So also, like even companies like Macromedia looked at it and said, "Hey, that's a great plugin system. We're gonna make MOA." There's like 12 different COM clones because there is something to it. And then character runes. Okay, that's the idea that like you can have a directory and it has interfaces. It's like a COM object, a Olay object with multiple or a Java object, and those interfaces are uppercase character.yaml, uppercase room.yaml that are declare it as providing this interface. So you can look at a directory as both a character and a room at the same time, which is great if you're doing like Pee-wee's Playhouse and you want a talking room that remembers what happens in it. There are applications of that, and we'll get to that. So naming and structure as reflection. So having a consistent big Indian naming system where you list the first thing, the most important thing first, and think how are these going to alphabetically sort so that related things are next to each other, and implied structure with shared prefixes. So, but anyway, listing a directory is saying what interfaces and state do you have. So, and then the thing is naming files and directories as self-describing, big Indian, human and LLM friendly K-lines. K-lines are a concept from Marvin Minsky that are just like it's a token that refers, it's a string you pull that points to not just an idea, but the whole cloud of concepts around it and what you were thinking of at the time. So the idea is to have and define and just more importantly reuse well-known words as K-lines, and then you can just, they're like pointers to thought. So the directory listing, the K-lines are the file names and subdirectory names that are pointers to files and subdirectories. The name explains itself. And then something we borrow that's really powerful is Will Wright and Jamie Dornbos invented this thing called advertisements, which sounds on its face obscene, but news called interests, event interests, a template for an event that you would like to receive, and then what to do when you get it. So Sims advertisements are on objects, and it's the key to the Sims plugin extensible object system that allowed to be so successful by enabling players to make their own objects and EA to make their own expansion packs that drop into the base game and just work seamlessly. So it's a successful way. Their capability announcements that I'm a stove and you can cook on me, and if you're hungry, you'd probably want to do this. So an advertisement is like a name of some function that you can provide, but also some parameters and some code that can score how much you want to do based on the context, who you are, what relationships you have to people, what your mood is. The toilet advertises that it can move your bowels if you need to go to the bathroom, but not if you don't. So the bed, you remember which side of the bed to sleep on, because when you sleep on that side of the bed, that makes a relationship with the bed that improves every time you do, assuming you have decent experiences. And that weighs the sleep in me advertisement of that side of the bed. Okay, so you, by doing it, you're increasing the chances that you'll do it later. So anyway, so think of the LLM as having a program counter of what to look at next. And all these advertisements, like whether they're a file name or a directory name or something out there in associative memory, the fuzzy search, the vector store. Or, here's the important thing, K-lines are greppable, okay? You can do very cheap, very fast, find me all advertisement, or all references to the word advertisement in this, or these 12 repos. So and then the LLM does that to like, what should I look at next to add to my context. So we'll go over that. But latent space inheritance, this is the great thing. Self, and many languages, a lot of which were inspired by it, point to a set of parents, and those parents are like made out of the same thing, right? But the thing is, with an LLM, we can have parents that are concrete files, anthropic skills, MOOLM skills, or just whatever prototypes. But we can also inherit from abstract concepts like love, or more concretely, Microsoft Calm I Unknown, or the Google GCS file access API, or a function that returns a pointer to an array of strings. Okay, so we can inherit from single words that name something, like the name of a library, or the name of the name of something that's well documented in the training data is what it matters. Or we can even have even looser natural language inheritance, like I inherit from a taco with crispy shell and hot meat and vegetables overflowing and sauces. Okay, maybe I'm defining a new food, but it wants this particular type of taco I can describe in a few words as a parent, and then we'll start from there. So, but mixing in literally different types of inheritance from a very concrete thing to something that's in the training data, okay, that you only have to ask by name. K-line. Anyway, where were we? So they're in the training data. You can inherit a whole language, a protocol, another object system. You can inherit object systems. Like when I'm defining the MOOLM object system, I want to inherit self's object system just by saying one of my parents is self's object system, and another of my parents is U.S. patent number 12345, filed by David Rosenthal and Owen Dinsmore, about how to convert a file system into, and the shell and paths into, an executable tree of objects. Okay, so you can inherit by referring to a U.S. patent. Okay, and hopefully that patent's expired, or it's in your name, or you might have legal troubles. But fortunately, Rosenthal's and Dinsmore's patent is expired. So, and it helps to have some naming discipline, and failure modes, graceful degradation. So, anyway, so there was an interesting Hacker News discussion about utrackdb, and I think versus is too hard a word. I mean, I want to inherit from utrackdb the great things about it and build on top of it. I'm not saying this is an alternative to it. They're very different. But utrackdb, JetBrains class-based object-oriented graph DB. And we compare in order to inherit what each is better at. And the machine language move, you see, this is like Java VM executes it, but we're being executed by an LLM. However, we'll get to this later, this Dublin core thing. We do want to have kind of a machine executable core. So we can make adapters, bridges, and emulators to different object systems. Any Python programmer that has used like PyGTK knows that it has a G-object wrapper for GTK's object system to like bring that into Python, and or like Swig to plug a library, or a library that just happens to have an object system into Python and make bridges so that you can subclass objects defined in another object system. So all this has been done with like C and C++ and stuff, but we are purposefully doing it in the LLM execution engine virtual machine. So the LLMs can just like imagine virtual machines and then be them. So I mean, they are. So live object examples. Okay, so we have like, we're using these for actual things and then learning from them. Ground up software is my company, and that's how we do it, from the ground up, or like hamburger, or used coffee beans. But so the system is running in public. So Soul City, Micropolis Core, Soul's Content Human LLM collaboration, and Adventure 4 is a built-in world example. So Dublin core and the adventure compiler, the strict machine executable core under the rich semantic overlay. Natural language guards compiled to guard.js by an LLM resolving linter warnings. Instance first, not yet lifted. The good, not the evil racist, but the good creative Scott Adams lineage who made Scott Adams Adventureland on the TRS-80 and Apple II. So now I have a new buzzword for you. Human-splaining. Its meaning is obvious. It's like the complement, the other direction of AI slop. So the named anti-pattern, wasting tokens, telling an LLM what it already knows. AI slop's mirror image, the skill script case study, capability confinement belongs in the runtime, not the grammar. So we'll get into human-splaining, but then I'll provide an annotated bibliography. Every YAML source cited by this series annotated as human-readable prose with links back to the live files. One ladle from the repo's cream layer. See, ladle is a K-line that refers to the cauldron skill. So we'll get to that later too. But okay, reading order. First read about self and MOOLM, latent space inheritance, the case studies, the annotated bibliographies, the cite table. Consult it when a citation points into YAML and you don't want to context switch. So the heritage, one line each. Self, Unger and Smith, 1987. Clone override delegate is the risk core that everything lowers to. SOAR, small talk and a risk. Ungerson, Patterson, Sequin, Berkeley, 83 to 85. Small talk and a risk. The minimal primitive discipline self grew from. List machine, flavors to common Lisp class to meta object protocol, MOP. Howard Cannon, Moon, Bob Rao, Kick Zales, etc. Mix-ins, method combinations, multiple dispatch, open implementations, before and after daemons, and around. So news, TNT, the news toolkit, Hyperlook, inspired by HyperCard. This is, it was a shipping window system, a shipping end user interface construction and editing system, like HyperCard, and then a shipping game, SimCity, on top of all of those. So Owen Dinsmore, James Gosling, David Rosenthal, me, Don Hopkins, Arthur Van Hoff, who ended up after that writing the Java compiler in Java, etc. So it used multiple inheritance object-oriented PostScript, inspired by Smalltalk, of course, shipped as a system software. HyperCard like editable, scriptable UI, and SimCity as live objects that you could deconstruct the game's user interface and build it back. So Owen Dinsmore and Rosenthal then, after doing the news object-oriented system, realized, news took Smalltalk's objects and implemented it on what PostScript was already doing, which includes a dictionary stack for looking up names, which is all you need, attention is all you need. We would say dictionary stack, PostScript dictionary stack is all you need to implement multiple inheritance PostScript. And guess what? That's isomorphic too, a shell path within a file system. So you can do objects. That is what this patent is about, okay? So, boom. This, we can inherit from this. This is a K-line to this patent that explains everything, okay? This is it right here. So, Gary Drescher. He was Marvin Minsky's graduate student. He made Made-Up Minds in 1991, and that inspired us at Lila AI, who Henry Minsky is my colleague in the CTO, Marvin's son, of course, to do a schema mechanism. We hit the wall was in Lisp or Python is that there's no grounding, no way to do grounding, right? Well, guess what LLM does really well. So anyway, earlier back, Minsky has written about K-lines, which I think I touched on, and then especially Society of Mind, which this gives you a much better perspective and way to frame and co-locate agents in the same LLM call, not having a whole bunch of agents talking to each other by serializing and deserializing pay per token, it's like prisoners in solitary confinement exchanging notes by writing in lipstick on wet napkins and then sending them back and forth with carrier pigeons. instead of having everyone in the same room together, okay? The distortion and the cost caused by serializing and deserializing like high dimension vector pointers to ideas, the noise that you're introducing, and the fucking climate change that you're perpetrating, just for doing that incredibly inefficient thing when you could just put them together and they just like point to each other's ideas in the same LLM call, GPU memory. Okay, so applying society of mind to LLMs, there are like really good ideas that you can do to make it much more efficient. And not just efficient, but like be able to do things you couldn't do before. So the activation mechanism and the agency model, agency composed of multiple agents that can communicate efficiently, like telepathically, okay? I mean, literally, they're in the same spark of if you would call it consciousness or not, it doesn't matter. They're in the same LLM completion call, in the same context. The whole thing runs on, okay, and now here's we're getting retro, COM, OLE, and ActiveX. Multiple interfaces per object. See, Java had to, like, self-inspired Java in JavaScript, but they made crippled implementations of it. And, I mean, they all had their own design trade-offs and, shall we say, time constraints. But Java doesn't use multiple inheritance of implementation. It separates that out into, and so does C#, into interfaces that don't have implementation. So you can multiply inherit interfaces, and then it's up to you to implement those interfaces behind the scene. C++ supplies this. COM is simply looking at C++ multiple inheritance, vtables, objects that have multiple interfaces having a sequence of vtable pointers, and then query interface casting a pointer between these pointers to vtable pointers, and then query interface being the first function in the vtable, allowing you to pivot between interfaces. Right? This is a great idea. As horribly as it was, like where it led, I didn't even put decom into here because that's where it gets really grisly. But there's some great ideas in there. So my cat's meowing. But anyway, query interface translates to just, is there a foo.yaml file in this directory that declares and implements the foo interface and could contain any state that foo might need it, but you also have the entire directory for shared states, like the C++ concrete implementation class behind the facade of multiple interfaces. So anyway, so skills implementing this. We've got a lot of skills. See, these are MOOLM skills. Prototype is the MOOLM skill that defines how you can use directories, objects, and files and skills themselves as prototypes for other directories and classes. Classes are just something you can implement with prototypes when treating them a certain way. An object, this is the object system with definition within the object system. Artifactory is the idea of objects that make other objects and protocols that they can follow and how they relate to these other skills. Skill, the meta skill. Everybody's got a skill. I mean, Anthropic even has a skill for how to make Anthropic skills, but these are more than Anthropic skills. So there's a lot of stuff in the skill here. File system object. Like I've explained that K-line, society of mind. Incarnation is a protocol for creating characters richly and ethically. And there's character, of course, and then empathic templates, or instead of like mustache templates with a certain syntax, you just explain to the LLM what you want it to fill in. I mean, why run? I mean, if you're running it through an LLM, why also run it through some very limited template system? So, and schema mechanism is Gary Drescher's schema mechanism, and schema factory goes with that. And then schema, oh my gosh, schema is a hot topic here. Leela AI is where I work with Henry. And now, see, schema is a very general term. There are many different types of schema. Schema, this is worth just hopping into. Schema is a veritable schemapedia. An encyclopedia is a circle of general knowledge. Consider this a schemapedia, a circle drawn around schema in every MOOLM sense that needs a name and a shelf. There's a lot of different schemas, and we're trying to catalog them all. So, or at least the good ones, not the W3C listed ontology directory. They have ontology repository catalogs, such as the bioportal and blah, 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 blah. Okay, and there's an old schemapedia thing out there that is not this. We're just reusing the name. Okay, but anyway, the idea here is here's schemas. What kind of schemas are there? Mechanisms. Mechanisms. Look at this. COM, XP, cursor mirror data set, Drescher, GitHub, JSON schema, K-lines, mechanism, Minsky frame, Postgres, relax ng, self, shell orchestration, society mine, SQLite. Plug your own schemas in. Like, we love Zod schemas. So why do we love them? Schemapedia Zod argument. Okay, I wanted to introduce you to YAML Jazz. Now, this one doesn't have a lot of comments, but the point is that you're just taking, you don't have a schema. You're making up schemas from the ground up. And if they're useful, then they propagate and get copied, and then later you play, you learn, and then you lift into formal schema definitions that are reusable and composed with other schemas. So these, we just pulled these out of our ass. In fact, LLMs are great at pulling things out of its ass. But like, you can understand this by reading it, but so can the LLM. And the other thing that we don't see here are like comments, end of line comments saying, like, why did I set this to this? What was it before? And then also you can have multi-line comments of any number of lines. It's like arbitrarily high bandwidth, out of band overlay of semantic information that humans and LLMs can read and write. So in general, you want your tools to preserve comments because comments are precious. But anyway, I digress. Let's go back to Zod and mechanisms. And so this is a skill all about schemas in general, schema mechanisms. And now it's just knowledge that we can draw from and be inspired from and refer to with paths, very concrete, instead of just abstract K-lines. Because, see, if I just go and I say data set, well, that, like, obviously you can Google for it and you can read why it's so cool. But now we've, like, reified it into our concrete thing and, you know, formally defined that it is named this and how it works and where you can go to get more information. So that's what we're doing here. But anyway, I digress. Let's see. Did we get to the end? No, we were just on. Oh my God. So schema, Lila AI. We do neurosymbolic AI. We do manufacturing intelligence and real-time computer vision. But then with a layer, I mean, computer vision is like the neat AI, the mathematically, you know, it's a black box. It's fuzzy. We don't know how or why it works, but we do not know from whence they come. But we neurosymbolic AI layers and sandwiches and mixes in symbolic AI of the, you know, the old school fuzzy. It's like physics, like versus biology. Okay. See, physics can be explained with mathematics, but biology is all exceptions and ad hoc rules. That's kind of the fuzzy AI versus neat AI distinction. But the conclusion that when they had all these discussions back when they coined those terms is that we need both, and they're both good for things that the other isn't. So anyway, the kernel directory is objects, selfish COM implementation I touched on, and we have like a constitution, you know, like lean into the training. Don't make shit up like Gastown for no fucking reason. We'll get into that. So prior design, selfish influence, Garnet Amulet prototype system. I work with Brad Meyer at CMU, and in CMU, Common was, of course, not a user interface system that used constraints using the KR knowledge representation system, and Lisp could like parse your expressions, figure out what they depended on, and automatically wire up a dependency network and do. It actually used poll constraints. So when you need it, you read it and recompute it if anything it depends on has changed. Where like OpenLASLO uses push because that was more efficient to implement in the Flash engine. So Garnet and OpenLASLO were prototypes for reactive programming, which React claimed, but all React is iterating on DOM shadow. No reaction, no reactive programming, no constraint tracking, while Svelte comes along, especially Svelte 5, and actually ships a reactive system in the spirit of Garnet and OpenLASLO. But so prototype, fragment config, directory as I unknown, moo heritage from Lambda moo, Pavel Curtis's work at Xerox PARC. And linguistic motherboard was John Warnock's invention and intention for PostScript, where it's just a motherboard for plugging in cards, and the first card he plugged in was graphics, stencil paint, Porter Duff graphics rendering to a bitmap to print. But there's also like a networking card, and there's now we've got like an LLM inference card, and so. But the idea that when Owen Dinsmore worked at Apple, he was making Apple's printing system, and he went over to Adobe and worked with all these people at Adobe to understand what the hell they were doing with PostScript and how can we make that supported by the Mac operating system and develop a product like the laser writer that fucking revolutionized desktop printing and publishing. So he got this idea of the linguistic motherboard, and then he went to Sun, and James Gosling took a step back and looked at all the Windows systems and said, like, how can we make a Windows system that sends code instead of commands, a limited command set like X Windows? And then Owen saw this, and it's PostScript. PostScript is like Lisp crossed with Forth, but more Lisp than Forth because it's like its data is polymorphic arrays and dictionaries, exactly the same as JSON, okay, instead of like typed binary crap that Forth, I love Forth, but it's very low level. Okay, PostScript, in one page of code, Owen implemented a Smalltalk-like class system, object-oriented programming system, on top of which we built user interface toolkits, applications, even Hyperlook, several versions, Good News, Hyper News, Hyperlook. There was like other things between there, but user editable environments out of this object system that was just like designed to run on a PostScript interpreter. It also ran on the printer. I have like really cool pictures. So, and then also we draw from the lineage of visual programming. Don't even get me started. But anyway, so this is broken up into, this is just the README, and I will go over the rest of the stuff next.